to pause the video and get the definition written out and resume playing once you have everything done. First off, let's talk about what is a function. Now, a function is a relationship that pairs each input with exactly one output. For example, we've been working with linear equations, and if I just have an equation such as y equals 2x, for every input, so if I put a number, say 5 in for x, 2 times 5 then gives me 10. 10 would be the output. This is a function. I can't put 5 in here and end up with more than one answer on this side. That's what makes a function a function. Secondly, let's talk about domain. I'm going to define it first and then we'll do some examples. Domain is a set of all possible input values typically associated with what we know as x. So in our last example, the domain would be if I put 5 in, if I put 2 in, if I put -7. Those are all the domains, anything that you input into the equation or function. And then conversely is range. Range then is the set of all possible output values typically associated with y. And so any answers that you're receiving once you put it in for x and you get the output of whatever answer it is, those would be the range. Again, we'll do some examples here shortly. I found this picture, which I like, a function machine. It just means if you're putting something in, there's something that happens to it, you get something out. This can be replaced with any equation that we've done. Y equals 5x plus 2. We put a number in for x, we end up with one answer for y, also known as f at x. Okay, let's do some examples. Example 1. I would like to know what is the domain and what is the range? Okay, so first off, if we take a look at this graph, it's a little bit different. It does look like it's linear, however, it's not connected, so we don't need to worry about the points in between. Let's write what we have. First, identify your coordinates. It looks like I have -2, 0. Next up, I have -1, 1. Next is 0, 2, 1, 3, and squeezing it in is 2, 4. Okay, so the domain then is going to be all of your input values, and like I said, typically associated with x. That's this one, and this one, and this one, and this one, and this one. And so when you look at it, you would simply say the domain, whoops, I need to change out of this, domain, sorry, okay, we'll try that one more time. We would say domain, spell it right this time, is -2, comma, -1, comma, 0, comma, 1, comma, 2. Now, if this would have been a connected graph, we could have put -2 through +2, but because it's just separate points, we have to keep them separated in terms of their answers. Finally, range then is going to be, well, what did we end up with for our output if we were to put -2 in? Well, if we put -2 in, we ended up with 0. If we put -1 in, we end up with 1. 0, we end up with 2. 1, we end up with 3. And finally 2, we ended up with 4. And that's simply your answer right there. The domains were all of your x values. The ranges were all of your y values. Let's take a look at one more example here. This time, you have the function y equals -4x plus 14. and that gives you the number of avocados you have left after making X batches of guacamole. Yummy. Okay, our first question wants to know the independent and dependent variables. Now, this is something we're going to begin using more often in class. I know you use them in science. Independent is, actually, let's start with dependent. This one's easier for me to understand. It depends, oops, depends is another way to think of it, on the independent. Okay, so if we look back to our definition here, which one is dependent on the other one? Take a look at this graph. Well, it looks like the input, your x's, will actually tell you what your output's going to get. So your dependent is always going to be your y, and then your independent is x, where you can choose what numbers to put in. So let's take a look right here. The dependent then, I'll use a different marker. Dependent is the x, and then the independent is the y variables. Next up, the domain is 0, 1, 2, and 3. What is the range? Easiest way, I think, would be to make an XY table. We have 0, 1, 2, 3. Perfect. Ooh, that's big. Let's try this. Make it smaller. Well, looks like it's going to be this size. We'll use it. Okay, so if I label it, we have the X and the Y. And your domain, they're giving you the input is 0, 1, 2, 3. Now it kind of makes sense because if you remember, we're talking about avocados and the number we have left. So let's just assume that we're talking whole avocados. And then we simply fill in our table. It looks like we will have, if x is 0, y is 14. If x is 1, negative 4 times 1 is negative 4 plus 14. We end up with 10. If x is 2, negative 4 times 2 is negative 8 plus 14 gives me 6. And finally, 3. If x is 3, negative 4 times 3 is negative 12 plus 14 gives me 2. Therefore, the range is equal to 14, comma 10, comma 6, comma 2. Now, the question always is, what if I wrote 2, 6, 10, 14? Well, general rule of thumb is if they write it 0, 1, 2, 3, keep the answers in the same order that they are telling you the domain is. All right, with that said, we'll try some practice problems. If you have questions on this was from lesson 5.1 out of Big Ideas. Have a great afternoon.